Well, the proposal was built around constructing these mini AUEs, autonomous underwater explorers. We're trying to make a fleet of them. They'll be about the size of a milk bottle or a large soda can, and they'll be controlled by larger sort of Sputnik-shaped ones that are floating around in the ocean. The thought is to put dozens or even hundreds of these out in the ocean. They'll all be sampling the properties of the ocean, both the physical properties like temperature, salinity, and water pressure, and also hopefully biological properties like phytoplankton fluorescence or perhaps even acoustics for looking at zooplankton.
So not only would these things be less expensive, could we make more of them? Could we sample the ocean on finer spatial and temporal or time scales? But they would put us into a whole regime of physics and biology that is totally inaccessible right now.
Having this unique sampling system in the ocean will really help us understand how the organisms in the ocean live their lives. All the sampling we've been doing so far has been point sampling, very coarsely spaced in time, and or sampling at one point continuously, but that tells us nothing about the actual interactions within a water parcel. So these underwater explorers, these vehicles, will allow us to understand what's going on in parcels of water as they track it. And so we can get a much more intimate view of the ecosystem dynamics of the plankton on the scales that they live their lives. We can also look at pressing problems such as pollutant transport. We can track the formation and transport of harmful algal blooms. Hopefully we can track the advection and movement of larvae and particularly larvae of endangered species as they move from the adult habitat out into the plankton and then back to the adult habitat to see how far they move, what are the odds of finding a settlement area, and the connection among different habitats.
So one of the reasons for having a swarm of these vehicles is because we want to get good statistics about the variability in their behavior. It became clear to me that one of the bigger unsolved problems in oceanography is how these little baby animals are born and they spend maybe 1 or 2 or 3 months of their life at sea out in the open ocean, and then somehow they make it back and settle on shore in these intertidal areas or areas close to the shore. And so from a scientific view, we don't really understand how they can do that because they're so teeny, they really can't swim against currents. It would like you and I trying to swim upstream in a really, really strong river. And so as scientists, of course, we think everything is interesting. But now with the environmental stress and the anthropogenic stress, people are fishing a lot of the fish out. The environment is changing to a certain extent. California, as well as many other states, have decided to create these marine protected area or marine reserves. In fact, we have one right here in Scripps, which has been a marine reserve which has existed now for quite a long time. And so what happens is these little animals, we hope that they settle in these areas that are marine reserves so they can have babies, and the babies will have babies, and then we'll have grown-ups, and this will replenish some of the depleted stocks. So the bigger picture has to do with marine protected areas and restoring some of the populations of animals. We're talking about everything from, sea urchins to Garibaldis to other animals. And so we as scientists, of course, think that everything is interesting, but this environmental necessity for creating these marine protected areas and even putting them in places where there's enhanced settlement of these animals has spawned a lot of interest on my part in creating instruments that could in fact sample the ocean in order to learn about the answers to these very interesting questions.